Now, it's being seen as the great hope for generating clean power, nuclear fusion. Today, scientists in France start assembling an enormous international nuclear fusion reactor known by the acronym ITER. French President Emmanuel Macron is hosting a ceremony to mark the milestone. It's already taken 10 years and a global scientific effort to get this far, and now the main construction of the huge complex in southern France will begin with components sent from all over the world. The idea is to create energy not by splitting atoms like nuclear power stations do now, but by fusing them together.
For decades, scientists have been trying to tap into the power that drives the sun, nuclear fusion. The hope is that it can be used to meet tomorrow's energy demands. The basic science is that in conditions like those found in the sun, such as very high temperatures, hydrogen atoms will fuse, create helium and release a lot of energy. The hydrogen could be extracted from seawater, making it a practically unlimited resource.
Fusion is basically the opposite of conventional nuclear. So in nuclear power, you're splitting a heavy element, and that releases energy, but you end up with the products afterwards, which can be quite hard to handle. Fusion is not a chain reaction, and so there's no possibility for it to run away, which is what causes meltdown.
Scientists at this startup in the UK are working on nuclear fusion. One of the biggest hurdles they face is how to get more energy out of the process than they have put in. Researchers in southern France are also working on fusion. The international project ITER is building a giant experimental reactor. It seeks to use heat to cause hydrogen to fuse. The reactor design is what's called a tokamak, a huge hollow donut filled with super hot hydrogen plasma that flows through it like a ring of lightning, held in place by powerful magnets. It has proved to be a major technical challenge. And it's still hard to predict how fusion energy can be fed into the power grid. Many think it could take at least 2 more decades before this problem can be solved.
We are now joined by Hartmut Zohm, one of the German scientists involved in the ITER project. Professor Zohm, the tokamak reactor in France is a giant experiment involving scientists from across the world. What is it hoping to achieve?
So what it's hoping to achieve is the proof of principle that we can get net energy from nuclear fusion on Earth. As was said, this is the source of the energy of the stars of our sun, for example. So we're fusing hydrogen nuclei. We have to make these very hot. It's gas, which goes up to 100 million degrees. We have made this possible in our experiments already, but we always had to put in more energy to heat up the gas than the energy which is released from nuclear fusion. ITER will be the first experiment that shows that we can get a net gain, so more energy from fusion than we deposit in the plasma to heat it.
Now, nuclear fusion has been called the holy grail, if you like, of clean energy. Is it really as safe and green as it's cracked up to be?
Okay, that of course depends who is going to crack it up to be. So I think it's clear that it will be sustainable because the primary fuels are deuterium, which is a hydrogen isotope from seawater, and lithium, from which we generate the tritium, the other hydrogen isotope. So lithium and deuterium are very widespread across the world, and they are enough to sustain for hundreds of thousands of years our energy demand. So it's clearly sustainable. It is clean in the sense that it does not produce any CO2 or any emission of gases which you do not want in the atmosphere. It is also safe because it cannot have this sort of uncontrolled meltdown of all the device or so. The energy contained in it is not enough for this. It does, however, produce radioactive waste. So the structural materials around, of which the machine consists, will be activated, but different from fission, these will have a half-life time that after, say, 100 years, you could touch and reprocess them. Very different from the millions of years we are talking in fission, where you really have to put things deep underground and store it away for long term. So there is no long-term storage envisaged for the radioactive stuff which comes out of nuclear fusion reactors.
All this sounds fantastic and ideal. Therefore, when can we expect to see our energy needs powered by nuclear fusion?
Okay, this depends a bit on your strategy. So if you do this sequentially, like we do in the EU, we will have ITER going into operation projected in up to 5 years from now, and then showing the net energy gain around 2035. We would then decide to build a follow-up real reactor, which would also produce net electricity to the net, which could do this by in the 2040s or say 2050, and then it could be deployed. However, if you are more hungry for energy, like the Chinese, for example, they are thinking about building a demonstration reactor in parallel to ITER. So this could produce electricity by 2035 or 40 or so, so 10 to 15 or 20 years earlier. And so the deployment could also be these 10 to 15 years earlier. It depends a bit on your strategy and how much you want it.
Hartmut Sohm from the Max Planck Institute. Thank you so much, sir.
You're welcome.